everybody, and welcome to CW Trending. My name is Jeff Sloan. I'm Editor-in-Chief of Composites World, and I'm joined by
Ginger Gardner, Senior Editor at Composites World. Hi, everybody.
So CW Trending is, this is the first episode of CW Trending, and we hope this will be the first of many. But the question is, what is it? And it was the brainchild of Ginger, so I'm going to let Ginger explain what CW Trending is.
So for me, as I'm writing articles and writing blogs and talking to companies around the world, I can see trends building. I can see things coming to a tipping point, and I wanted a way to share that with our readers. And just, sometimes it takes us a while for the article to come out, for us to develop a blog, develop an article, get it up online and send it out to you. So in the meantime, while we're doing that, I wanted you to see what's coming up and what's going on.
And I would say on top of that every day, Ginger and I, Hannah Mason and I, Ginger and Hannah Mason, we have discussions about what we're working on, what we see happening. And we just thought it'd be interesting for you, the audience, to have a glimpse into those conversations and see what we see and hear what we talk about. There is the hope also that with CW Training, we can also bring in people from outside CW to talk about what they're working on and what they see happening. So this will be a multi-pronged effort. So Ginger, why don't we go ahead and get started? I know you have a presentation prepared. Why don't you bring that up and we'll get going.
This first episode is one that I pulled together on what I'm seeing with regard to the democratization of composites. So the topics involved in this for me are automated AFP cells for small and medium enterprises, SMEs, more and more capability coming in-house for suppliers, for example, the ability to make their own dry tape, online portals for ordering tools, parts, similar to what we can do now with Amazon, etc. Robotic computed tomography, CT, which is an X-ray technology for non-destructive testing, and then robotic injection molding. All right, so the first is AFP cells for SMEs. And this is based on some reporting I've done with FMON, which is a company in Canada that does composites automation. They started a project to integrate and add composites AFP head into a Fanuc robot they had on site. So for those of you who haven't seen my blogs on Add Composites and all the press releases, they're a company out of Finland, and they have this plug and play AFP head that they ship to you in a box, kind of like a Dell computer. You unpack it and you plug and play. They're also unusual because they're kind of upending the AFP market. Instead of buying $1 million system, you're buying a much less expensive system, or you can lease it. So you can, I think, lease it for a few thousand euros a month for the duration of whatever you've got going, and then send it back. So the goal with this project between FMON and Add Composites was to create not pre-preg layups, but dry tape layups. So these are high permeability preforms that they would then use in RTM or light RTM. And if you can see that picture on the right, what they're actually placing is kind of a woven tape with glass fiber. So it's really unusual. It's not what we're used to seeing come out of an AFP head. And it just goes to show kind of the innovation that's involved. That tape is something that FMON came up with and worked with Add Composites to do. And then also what the real target is. So it's to put equipment in the hands of small companies and fabricators so that they can build new kinds of parts using the same kind of processes that are being used by tier ones for Boeing and Airbus. So automation and liquid processing. Another aspect to this democratization are increased capabilities in-house. So you have AFP coming in-house in a more effective, cost-effective way, and now you have dry tape. And this was an article that I wrote this year. There was a back-to-back series with Torres, first on their dry tape line that they've invented. So if you look at the picture in the bottom, you can see this big hall with production equipment in it. And on the left side is a glass fiber dry tape line. And on the right side is a carbon fiber dry tape line. And you can see a spool of that tape and then some close-ups of it. And it's pretty interesting. This effort came originally out of their work with wind blade manufacturers and trying to come up with a way that wind blade manufacturers could use AFP that was affordable. Typically, the tapes that are sold for AFP machines are not affordable for something like a wind blade. So what they wanted to do was go with the cheapest fiber possible, a 50K carbon fiber tow or 4800 Tex glass roving. And they developed a line that can go 5 to 10 times faster than what's being used by tape suppliers right now. So you can get the cost down, better utilization on the capex of the equipment. And the goal, again, is a high permeability tape that you can make preforms with. So what they did for that permeability, if you can see in that lower right-hand picture, there are slits that they put in the tape. Now, these aren't cutting fibers, so the fiber continuity and the mechanical performance is intact. It's just they move the fiber out of the way a little bit so that you've got better Z direction permeability. The resin flows through layer to layer quite quickly. And then if you see on the right-hand side, that's a more narrow tape. And you can see there are these circles, and that's a thermoplastic. That one holds the unidirectional spread tow together. They take 50K and spread it out. And that holds it together in a tape, but it also creates XY plane permeability. So it's kind of like a flow media that's built into the tape. And that's really important because if anybody has read our articles, you know that if you're going to stack 30, 50 plies of a UD tape, sometimes with carbon, that's a bit tricky to get the resin in there in the XY plane. So the permeability is both Z direction and in plane. The tape lines also they envision will help the industry be able to make small batches of new materials. We struggle sometimes because the large tape suppliers just want to run, thousands and thousands of meters of the same thing, and they're not necessarily responsive to companies that want to try new things. And so the idea is that through this kind of approach, you could do that. You could have companies really pushing the envelope of what's possible with new materials. What mTORs then did was trial this tape in a Clean Sky 2 project where they built this wing box on the lower left. And so that's a one-piece wing box, everything except the top cover. It's the lower wing cover, the stiffeners for that cover, the forward spar, the rear spar, and each of those spars have stiffeners. And that's what you see there. And again, that was an article I wrote for March.
Two quick questions. On the FMIN Add Composites innovation, is this just a matter of scale, that it's accessible and affordable, or is there technology here that's being implemented that we don't normally see in AFP?
Well, for one, the plug and play head is something we don't normally see. So that was a real disruptor when it came out. The concept of trying to, scale it down, make it really accessible for people that haven't normally been able to get their hands on it because of cost reasons. The other aspect of it is really this partnership between FMON and Add Composites to work together to make these cells. FMON, apparently that's their specialty, is making these cells that are affordable in a range of industries. And, this is what they saw as a real potential market in North America right now is it doesn't have to be the end all be all. You can make a machine that can meet most of the needs for a parts fabricator and not have to cost as much.
Okay. And on the dry fiber, I know permeability is an issue, especially if you're doing infusion, which of course you have to with dry fiber. I'm wondering also, I'm trying to remember from your story, are there challenges with laying dry fiber and keeping it in place, and how is that addressed by mTORs?
So because they are an AFP specialist and they've been doing this for decades, they understand inherently the issues with laying dry fiber. They had a project that's included in these articles where they built a business jet size fuselage using dry fiber. So that gave them a really good understanding of what was necessary, and this project was developing in parallel to that. The tape addresses that. The tape runs really well in their machines, and it's very it's possible to do aerospace grade laminates with the tape in their machines. They've considered all of that in this development.
Okay, great. Thanks.
Yep. So the next topic is this portalization of the composites industry. So we're all familiar with going to Amazon or eBay or whatever and how easy that is for us to make orders and what we want can be searched using algorithms and suggestions made to us. Now we're seeing this happen within the composites industry. One of the first examples I saw was Pliable, and that's this big black box in the lower left. That's a company that if you want to make tooling to produce composite components, and that tooling could be anything from wood to plastic to epoxy foam to metal or a composite CFRP tool, it's that whole spectrum. You go in, you put in your CAD, you put in your what you think your material you want is and your volume and all this, and then it comes back and works with you to optimize the tool, and then they put that out to their base of manufacturers, their network, and then they come back and give you a delivery time and a cost. You click the button, yep, and you're good to go, and it gets shipped to you, which to me is just revolutionary compared to how we have operated. The other thing that's interesting about it is, they started in the UK. I mean, that's where they're based, and their network started in the UK, but I think it's quickly branching out from there. And that makes a lot of sense to me, because we have in the world, we have this network of all these manufacturers for tooling, for parts. A lot of the small companies do the whole gamut, right? They have to be a jack of all trades. And so now you have a new way to utilize that capacity, almost kind of Uber-like, where we've got standing capacity that's not always being used, and here's a way to take advantage of it.
Yep.
Dynexa is another example that I wrote about in the Composites 4.0 series I did last year. And it's almost the same thing, except just think about one individual supplier. So Dynexa makes carbon fiber tubes, really high quality, and drive shafts, etc. And what used to happen is that their customers would send in an order, email an order into them. They would run it through all their design software. They'd come back and say, yeah, we think, you should optimize it this way. We know you want this volume. This is kind of the timeline when we could deliver it, and this is the price. They just said, well, instead of us spending all that time doing it, we'll just have the algorithms do it. And so now, you have your customer login, you go in, you put it in their portal, it spits all that back for you, and it does it in a matter of, hours or a day instead of a week. And then the other thing that was interesting, because they've got all this going, it frees up their time to do more advanced development and more customization that they weren't really having enough time to do before. So it's a better use of their staff. But another part of it is that when they click the button, hit order, all of the paper trail is now embedded in a QR code that goes out on the tubes. Their customers told them they didn't want all that paperwork being shipped anymore. And so it's much easier for them to have a tube and be able to scan it quickly and know, yep, okay, it's this batch, it's this material, all that. Finally, the last example is Airborne on the lower right. And we saw at JEC 2019 that they were demoing this ability to put this automated line up. That line is up now. I think the line started with thermoset composites and is quickly moving into thermoplastic composites. And you can see kind of how that works. You upload your design, they help you optimize, and then they can make the laminate or part and send it to you. So it's really, to me, it's just a whole shift, a paradigm shift in how the industry will be operating in the future, sooner than later.
Yeah, and I think one advantage here is that if you're a manufacturer, an OEM who needs parts, you don't know composites very well, this provides a portal through which you can work and rely on other experts to help guide you and make some decisions and not feel like you have to know everything there is to know about composites manufacturing. We should also add that Airborne just announced their expanding operations into the US just last week. So certainly that model is growing. And then I should add too, there's another organization that's actually a consortium in the UK called DASIS, D-A-S-I-S. And this consortium is a group of manufacturers, including composites fabricators and CNC specialists and 3D printers, injection molders, tool makers. Again, DASIS acts as sort of a project manager and front person for OEMs who need parts, and then they work with their consortium to get those designed and fabricated. So a lot of these models popping up, and I think it's going to be really interesting to see how these unfold.
That's a really good point you made about the expertise, and that's one of the things that basically Dynexa and Airborne both have said, is that they're taking all of their expertise and they're putting it into these algorithms and these AI software so that it's being given to you so that you don't have to develop that expertise. So that's a really important part. And the other one is that AZL and Aachen the industry group and research group, is also getting machines ready for portalization, and they see it coming as well. So yeah, it's very much happening. So the next to last slide is about robotic computed tomography and NDT, again, aimed at SMEs. Computed tomography has really grown in the last 5 years. I started writing about it with Exact Metrology here in the US, and they have that capability and they offer that service. And there are some other companies, Jesse Grant was offering that as well. And the capability to use CT on composites was amazing to me. You can get this 3D image and all the porosity and fiber orientation, injection molded or aerospace parts. Just the minutia, the detail, the granularity you get is amazing. And it was really helpful to these big companies to track out quality and processing. However, it's expensive. And so what would happen is that you end up going to these service bureaus, because a CT machine, basically you have a rotary table, you put the part on there, and then you have the x-rays being sent to that part, and the table goes around and you get a 360, right? What has happened now is this company out of the Czech Republic, Radolitica, they're a specialist in robotic NDT, and what they've developed, as you can see in the upper right-hand corner, is a collaborated robot system. So one robot emits the x-rays, and the other is using the next bit of the technology, which is these photon counting detectors. And this technology is being used by NASA. It's just really, really sensitive. So if you look at the lower left, what the two robots are actually imaging is a vase full of flowers. And if you look at the pictures in the middle that are kind of red and purple, and then below it, you can see all the parts of the flower. We're not used to getting, normally you can't x-ray a flower. You can't x-ray just tissue. You're looking at bone. But this is x-ray, and this is the granularity and then the resolution you get off of it, which is just mind-blowing, really. As you can see on that prop, the services that they can offer are imaging the surface, doing laser shape profiling, doing a full CT analysis where you can see the porosity and the orientation, and go layer by layer to see defects. So the goal really for Radolitica is to help SMEs access the technology that previously was really only available to large R&D groups or large aerospace kind of companies, etc. In the lower right hand, you see how they're controlling the robots. It's with a mouse, which I find fascinating.
And what about cost?
Yeah, the cost is still in the hundreds of thousands, but it's not in the millions. And it's something that is, you can work with them to tailor what you need. Again, you don't need end-all be-all necessarily, but it's definitely coming down in price, and it opens up a door to companies that typically wouldn't have access to this technology in-house.
Great.
And the last one is kind of the same idea of using robotics to bring down something that we typically think of as really large, injection molding. I know that's more of your background, Jeff, in plastics, but when we think injection molding, we think, 100,000 parts, really expensive tools, a big setup, really high pressure presses involved. And this is a different take. So Anhybrid is not Czech Republic. That's a copy and paste error. Sorry, they're in Germany. And that's a spinoff from the ILK at TU Dresden. And we've written a lot about them. They do a lot of really good work. What they looked at was functionalizing parts and how to get the overmolding, functionalizing that injection molding offers to a place that a company can bring it in-house. So they put it on the end of a robot. It's an end effector. And if you can see the red U in the top right corner, a lot of that end effector actually uses composites to make it lightweight. And the molding tool is actually in the very center, kind of upper center. If you look right below the orange robot, you'll see a twin pair of like metallic plates, a semicircle in the top and a semicircle on the bottom. That's the whole injection tool right there. It's miniaturized, and it's made to functionalize a part. So if you look at that tube with the red plastic on it, that's the kind of injection you can get on a carbon fiber tube, for example. And you can see other examples in the lower right hand where you could injection mold clips onto an underframe of a car, electric vehicle perhaps. And then you can also see a robot overmolding an extrusion coming out of a line in the middle. And what's really exciting for me is to see the examples they give you. So, I mean, think about with function integration there, those are LED lights it's showing. So you could actually injection mold, pockets for the LED lights, or, a fastener for a cord structure when you see the load application part here in the middle. And at the bottom, you can see there's red X's in the web of the I-beam. So, I mean, it's just fascinating where we could go with this. And this is a startup, it's new, but the blog on Anhybrid and the blog on Radalytica I'm working on now, and those will be up pretty soon.
Yeah, this is interesting to me because if you think about how this injection molding would be done without a system like this, as you noted, the machines tend to be much larger. Even something like this, relatively discrete parts, take that load floor in the lower right-hand corner, for example, you'd have to have a tool designed to accommodate that entire load floor, and then you'd injection mold around it wherever you want to injection mold around it. And that's not trivial. It's time-consuming and it's expensive. And it's really creative to capture all that technology in a relatively compact and obviously very manipulatable, easy to move around a part and to apply that technology in a way that I think really serves a lot of really interesting applications. So.
And the tool switch out is fairly easy, and it has a 1 meter reach, in from the side. So yeah, I'm like you, I see a lot of potential here.
Well, thank you, Ginger. Before we go, what are you working on right now?
Oh, let's see. We're finishing up a lot of articles on additive manufacturing of composites, which is really exciting. I think that's going to be a great issue that comes out in August. And getting ready to start an integrated antenna into an aircraft fuselage. And that comes out of the Netherlands. So
great.
Good.
Yeah. So the additive manufacturing supplement will, as Ginger just said, will be at the August issue. So you can look forward to that. And you can look forward to the next episode of CW Training, which will be coming in July. So keep an eye out for that. So thanks, Ginger, for doing this. I appreciate it.
Thanks, everybody.
Good to see you. Bye-bye.